To integrate this one, we're going to use partial fractions. So the first thing that's supposed to come into your mind is to check, is the numerator heavy, or the degree of x in the numerator, is it greater than the one in the denominator or what? But we can see in our question that this question is bottom heavy, where we have a degree of 3 in the denominator and a degree of 2 in the numerator, so we can't divide this one. But we are going to factorize the denominator and use partial fraction to resolve it. So we have 12 x power 3 plus 13 x squared minus 20 x plus 4. So we are going to look for factors that are going to give us a 0 when we divide into this expression. And we're going to use try and error method, where we're going to test plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. So we're going to test numbers number by number, plugging in where there's x, so that we check which one is giving us a 0. So the way to check it, for example, when you get a positive 1, you are going to say 12 open 1 to the power 3 plus 13 open 1 squared minus 20 multiplied by 1 then plus 4. So with this one, if we try to simplify, we're going to have a 12 plus 13 minus 20 plus 4. Clearly this one can't give us a 0, because a 12 plus 13 are going to get a 25, then minus 20 plus 4. This is simply 29 minus 20, which is equals to a 9 and not a 0. So this one can't be a factor. So when you try through all these numbers, you are going to find out that the only factor that is going to give us a 0 here, it's negative 2. So meaning that our x is equal to negative 2. When you try to plug in negative 2 in this function, you are going to give it's going to give you a 0, meaning it's one of the factors. So since we have this one, we can proceed to use synthetic division so that we factorize the expression. For synthetic division, we are going to pick the coefficients of the expressions that we have, then we put them here. So we have a 12, then we also have a 13, we have a negative 20, we also have a positive 4. With these numbers, we are going to divide through, we are going to use them to find the we are going to factorize this expression using these numbers. So the way to do it is, first we are going to drop this first number, which is 12. So we'll drop it here. Okay. So after dropping this, we are going to multiply negative 2 multiplied by this number 12. So when you multiply here, you get negative 24. With this negative 24, when you punch on your calculator to check, so we have negative 24 plus 13, we're going to get 11. So the answer that we get, we'll write it down here. Then we're going to multiply negative 2 times 11. When you multiply here, you're going to get negative, so this is negative 11. Then when you multiply here, you're going to get positive 22. Then adding this up, we're going to get a positive 2. Then negative 2 multiplied by this 2, we're getting negative 4. When you add these two, we're getting a 0. So this 0 is showing you that it's a remainder, meaning that the number that we've used here is one of the factors. So since we factorize, we're going to have, so since the degree here was 3, then what we are going to have here will be 2 power x power 2 minus 11x plus 2. The degree reduces when you factorize. Then this whole thing will be multiplied by, you take this 2 to this other side, you are going to have x plus 2 as a factor. So this one is linear, this one is quadratic. Let's try to factorize it further so that we see if it has factors or not. So checking for this one, we have 12x squared minus 11x plus 2. Then we are going to look for factors, then product and the sum. So the product for this one will say the coefficient of x squared multiplied by 2, which is the product, we are getting 24. Then for the sum, we are supposed to add two numbers that are going to give us 11. So the sum is negative 11. Then for the factors, we are going to look for two numbers such that when you multiply them, you get 24. Then when you add them, you get 11. And those numbers are negative 3 and negative 8. Negative 3 multiplied by 8, we get positive 24. Negative 3 minus 8, we get negative 11. Meaning that our simplified version was going to be x squared minus 3x minus 8x then plus 2. Grouping them together, we're going to have, we factor out 3x here, we're going to get 3x open. When you factor out 3 here, we're going to get a 4. Factor out x, you remain with 1x. Then when you factor out 3x here, you're going to have a 1. Then doing the same here, factoring out 2, we're going to get a positive 2 outside. So in this case, since it's a negative in the middle, meaning we're supposed to factor out a negative 2 to match the things. So factoring out a negative 2, we're going to have, when you remove negative 2 here, you have positive 4x. You remove negative 2 here, you have negative 1. Since the factors inside are the same, we can group them by saying 3x minus 2 multiplied by 4x minus 1. So these are the two factors that are going to give us a 0 when you plug in their values, including x plus 2. So after factorizing here, since they are now in linear form, we can put back in our integral and decompose them using partial fractions. So putting them back, we're going to have an integral of 49x squared minus 19x minus 18. Then we're going to divide everything by the roots that we found, which are 3x minus 2, then 4x minus 1, and lastly x plus 2. So decomposing this using partial fractions, we are going to say whatever is inside is supposed to be equal to, so let me just remove this part. So we're going to say whatever is we are having here is supposed to equal to a over, we're going to get one linear factor here and put it under a, so it will be 3x minus 2, then plus b over, we'll get this other factor which will give us 4x minus 1 plus c over the last factor, which is x plus 2. This is how we distribute linear factors. So after this, we are going to find the values of a, b, and c then we put them back, meaning that it's going to be our decomposed partial fraction. So to do that, we are going to multiply everything here that we have by our denominator. So we'll multiply this by x plus 2 multiplied by 3x minus 2 multiplied by 4x minus 1. So multiplying this throughout, it's going to give us 49x squared minus 19x minus 18. This whole thing will cancel out with this whole thing that we have in the denominator. Then when you multiply this by this other side, you see that 3x minus 2 is going to cancel out with 3x minus 2, meaning that what will remain is this will be equal to a multiplied by x plus 2 multiplied by 4x minus 1. That's for the part for A. Then for the part for B, we're going to have B open. You will see that our 4x minus 1 is going to cancel out with this 4x minus 1. Then the rest will multiply by B. So we're going to have 3x minus 2 multiplied by x plus 2. Then lastly, we're going to have C. Then we're going to multiply the same way. So we'll see that x plus 2 and x plus 2 is going to cancel out. Then the rest will multiply by C. So we're going to have 3x minus 2 multiplied by 4x minus 1. Since we have this, we can now start finding the values of A, B, and C. So the strategy that we are going to use is elimination, where we check how can we cancel out A and B so that we find C, and how can we cancel out these other letters so that we find the letter that we need. So to start with A, if we want to find the A, you check what is it that B and C has that we can cancel out. We can easily make the whole function cancel out. So for instance, you notice that at B and C we have 3x minus 2 and 3x minus 2. We can take advantage of that because we don't have 3x minus 2 here. So we can say we let x equal to something such that when you place where there's x here, the whole function is supposed to give us a 0. So in other words, we equate this to 0. So we're going to have 3x minus 2 equal to 0, meaning that our 3x is equal to 2. Then dividing through by 3, our x is going to be equal to 2 over 3. So we're going to use this value to put where there's x so that we eliminate these other letters. Doing that, we're going to have 49 multiplied by 2 over 3 squared minus 19 multiplied by 2 over 3, then minus 18. This should equal to A multiplied by, where there's x, we'll put 2 over 3. So we have 2 over 3 plus 2 multiplied by 4. So here we're going to have, we remove this part, we're going to have 4, then 2 over 3, where there's, okay, then minus 1. Alright, so we have 4x minus 1. Then when you put where there's b here, plus b, when you put here 3, 2 over 3 minus 2, this 3 and this 3 is going to cancel out. What will remain is 2 minus 2, which is a 0. And since this part is a 0, it will multiply by b and this part, and everything will go to a 0. So no need of writing it. The same thing as c. When you put 2 over 3 where there is x here, everything is going to be a 0, so no need of writing it as well, meaning that what you are going to find here is just the value of a. So simplifying this part, we're going to punch on our calculators, meaning that our a is going to be equal to, dealing with the inside, we're going to have this will equal to a open, we have 2 over 3, so we have 2 over 3 plus 2, it's giving us 8 over 3. So in other words, you can say 3 multiplied by 2, it's a 6, plus 2, it's 80 over 3. Then you multiply this by, here we have 4 times 2, which is 8 over 3. So we have 8 over 3, then minus 1. Then on this other side, we are going to have 49 multiplied by 4, which is 2 squared, over 9, which is 3 squared. Then this part minus 19 over 19 times 2 over 3. Then from there we're going to subtract 18. So the overall answer that I'm getting here, it's a negative 80 over 9 on this other side. Okay, so after finding that, we can simplify this other side. We are going to have a open 8 over 3 multiplied by, we have a 3 multiplied by 1, it's a negative 3. Then 8 minus 3, it's a 5. So we have a 5 over 3 here. This will equal to negative 8 over 9. Simplifying here, our a, when you multiply 8 times 5, we get a 40 over 9. This is equal to negative 8 over 9. Multiplying everything by 9 over 40 is going to give us our a, which will be equal to negative 40 here, it's 1, 40 here, it's 2, 9 and 9 will cancel out, so we only have our a as negative 2. So that's the first part. And the second part, we are supposed to find b, c, and b and c. So I'm going to erase everything, then write my answer somewhere. So we have a, which is equals to negative 2. Then to find b, we're going to use the same strategy where we say, is there anything that we can use that is on a and c that can help us to cancel out these two letters? So you'll notice that at a and c we have x plus 2 and x plus 2, which is not at c. So we can take advantage of this by equating it to 0. So x plus 2 is equals to 0. Then x will be equal to negative 2. So if you plug in negative 2 throughout, you see that our a and our c and our a and b is going to cancel out. So what we will have is 49 multiplied by negative 2 squared minus 19 multiplied by negative 2, then minus 18 is equal to, when you put negative 2 here, it's going to be a 0, meaning everything will be a 0. Then when you put negative 2 here as well at b, it's going to be a 0 and everything will be a 0. What will remain is c open 3 negative 2 minus 2, then multiplied by 4 open negative 2 minus 1. Okay, so with this we can say, when you punch on your calculator, we have 49 multiplied by 4, then minus, so negative and negative will be positive, so we are going to have 19 times 2, then minus 18. What we'll get here, when you say 4 multiplied by 49, then plus 19 multiplied by 9, then minus 18, we're going to get 216, which is going to be equal to, then on this other side you have a negative 2 multiplied by 3, that is a negative 6, and negative 6 minus negative 2, we get a negative 8. So we have negative 8 here, multiplied by negative 2 multiplied by 4, that's a negative 8, minus 1, that's a negative 9. So when you multiply here, you get 8 times 9, you get 72. Since they are both negative, it's going to be positive 72. So you have 216, which is equals to 72c, meaning that our c is going to be equal to 216 divided by 72. We'll get 216 divided by 72, we'll get a 3 as our value for c. So I'm just going to write it down. So our c is equal to 3. After that, we are going to use the same strategy to find the value for b. So one thing that b doesn't have but these others have is a 4x minus 1. So there's 4x minus 1 at a and 4x minus 1 at c, meaning we can take advantage of this to eliminate the rest. Doing that, we are going to have 4x minus 1 equal to 0, meaning that our 4x is equals to 1, then our x will be equal to 1 over 4. So using this value of x, plugging into our function, which is 1 over 4, we're going to have 49 open 1 over 4 squared minus 19 1 over 4 minus 18. This will give us, when you put 1 over 4 here, it's going to give us a 1. 1 minus 1 is going to give us a 0. So everything will go to 0. Then at c also, everything will go to 0. Meaning what will remain is b open 3 multiplied by 1 over 4, then minus 2, then multiply this by 1 over 4 plus 2. So punching this on our calculator, we're going to have 49 multiplied by 1 over 4 squared, then minus 19 multiplied by 1 over 4, then minus 18, meaning the overall answer that I'm getting on this left hand side is going to be negative 315, then everything over 16. This will be equal to, punching for this other side of the equal sign, we're going to have 3 over 4 minus 2 is giving us a negative 5 over 4. Okay, so a negative 5 over 4. Then apart from that, when you punch 1 over 4 times plus 2, it's 4 multiplied by 2, which is 8, plus 1, which is 9. So I multiply this by 9 over 4. Then when you multiply these two, we're going to get negative 5 multiplied by 9, we get negative 45. So just rewriting this other side, we have negative 315 over 16, which is equal to, when you multiply this, we are going to get negative 45 over 4 times 4, we get 16, then b. So using this, I'm going to multiply everything by 16 over negative 45, meaning that our b here is going to be equal to this one, and this one will cancel out, this one and this one will cancel out, then 16 and 16 will also cancel out, meaning that what we'll have here is 315 divided by 45. So I'm getting the value for b as positive 7. So I'm going to write this as well. My b is 7. Now that I've found all the values for the letters, it's going to be easy for us to just plug into the formula. So we're going to have the integral of our a, we said -2, so it's going to be -2 over 3x minus 2. Then our b is 7, so it will be plus 7 over 4x minus 1. Then our c, it's positive as well, it's going to be 3 over x plus 2. Then everything multiplied by dx. So what's remaining here is just to integrate what we have in our integral. Right? So to do that, we're going to say we take out all the coefficients. So first let's separate it. To see it properly, we're going to have -2 over 3x minus 2 dx plus the integral of 7 over 4x minus 1, then dx as well, then plus the integral of 3 over x plus 2 dx. So since we've split it, what we can do best is to factor out the numerator. So here is going to be -2 integral of 1 over 3x minus 2 dx plus 7 integral of 1 over 4x minus 1 dx plus 3 integral of 1 over x plus 2. With this, it's easy now to integrate because you know that it's 1 over, it's bottom heavy, so we can use natural logs. So here we're going to have -2 ln absolute value of 3x minus 2 plus 7 ln natural log of 4x minus 1, then plus 3 ln absolute value of x plus 2. So for the first one, it's just ln 3x minus 2. Second one, 4x minus 1. Third one, x plus 2. With this, we can say our answer is going to be just double checking what we have here. Alright, what we do next is to differentiate these denominators and divide by the whole expression. So we have 3x minus 2 here. When you differentiate it, you get a 3. So for the integration, instead of multiplying by the function, we are going to divide it by the function. So in this case, it's giving us a 3, meaning it's going to be -2 over 3. Then for this one, it's a 4x minus 1. Differentiating this one, we get a 4, meaning that here we divide by the whole expression. It's going to be 7 over 4. Then for this one, we differentiate, it's a 1, so it won't change anything. Then plus c. This one is now our final answer.